Hello everyone, my name is Donia and I will be one of your hosts today. Welcome to our webinar about Introduction to Mathcad. We're very happy that you all could make it here. Our presenter today will be Dustin Mayfield, Tech Safety's Application Engineer. We will have a short Q&A session at the end of the webinar, so please feel free to type in any questions that you might have in the question box, and we will make sure that we address all of them at the end of the webinar. We would also really appreciate it if you could take a few minutes after the webinar to fill out our survey. This will help us a lot in the future. And with that, I think, Dustin, you can take it over.
All right, thanks, Donia. Welcome, everyone. I appreciate everyone joining in. This is Introduction to Mathcad. My name is Dustin Mayfield. I work as an application engineer at Tech 30. The first thing we'll talk about is we're going to go over the agenda of today and exactly kind of how this is going to be formatted out. So we'll begin by a few PowerPoint slides talking about the overview of Mathcad, the Mathcad origin, leading into some of the challenges in current day engineering calculations, and how does Mathcad help you in that scenario. We'll then step right into a Prime 3.1 demo, and at the end of that we'll have some time to do a short Q&A session. So save up your questions, please put them in the question box, and then we'll get to them at the end, and we'll go from there. So to begin, a little bit of history on Mathcad. It was originally developed by a company called MathSoft in 1985, so it's quite old. It was later acquired in 2006 by PTC, which did a lot of R&D development on it, kind of really beefing it up, making it more robust and more applicable to companies in the current day engineering environment. So it's been a leading solution in the engineering calculation field for 20 years or so. Most Fortune 100 companies are using Mathcad that are heavy into engineering development. We've seen about 250,000 engineers currently using Mathcad, and we see this a big grasp in the education industry. There's over 500,000 users there from 2,000 different schools. So it's quite popular in a lot of different places around the country and the world. So it's definitely nothing new. It's been around for quite some time. It's been really well developed out and talked about and fleshed out any of the issues or bugs that it's had for a while. So it's a really nice, robust software. It's very current today. So in today's engineering world, we have some challenges in leveraging the engineering knowledge that we capture in our designs. What we see in today's environment is we still see paper calculations, whiteboard calculations, napkin calculations, referencing reference manuals, old textbooks, and then we put these all into spreadsheets or computer programs that might not be built for engineering calculations. You see a lot of these done in Excel most of the time, which is, Excel's a great tool. I'll definitely agree with that. It's a great tool, but it's not meant for engineering calculations. It's more of an accounting software for doing basic, 1 plus 2 kind of calculations and having that neatly organized. But engineering needs to take that one step further. So hopefully Mathcad can resolve those issues. So we see multiple tools being used in multiple different mediums for data. They're all stored at different locations. We have to all manually consolidate these to create deliverables. So when you go deliver your final design, you need to bring all those napkin sketches and paper calculations that you did. Traceability is extremely difficult to figure out in this case. And this is pretty important, especially when you're dealing with industries that require a lot of oversight and traceability. It's hard to deliver your package when it's in a format such as whiteboard calculations or Excel spreadsheets. There's not a lot of good traceability, and you can't really figure out what you were doing when you were first doing those calculations. So, and also it's difficult to redesign or make a new design with those calculations you've done on paper or in Excel. It's harder to reuse those calculations. So we need an easier way to manage our engineering calculations in a nice, neat, professional format. So that's where Mathcad helps. We kind of mentioned this on the previous slide, but engineering methods are very iterative, right? It relies heavily on intuition and experience, CAE applications, and then making a physical prototype. Computer-aided analysis helps with that, obviously, but we're missing a step here, where we're kind of missing the step of formal calculations. where we don't do the calculation beforehand, and rather we do the design first, then throw it into an analysis tool, figure out where the issues might be, and then go back, redesign it, and then put it back in an analysis tool. So it's really iterative. We're going back and forth, and it's more of a guess and check rather than we get it right the first time and maybe do one or two analyses and get to our final design. So Mathcad helps by kind of taking away that iterative process and making sure you kind of get it right the first time and have that traceability to figure out why you came to the dimensions or the geometry that you did. So how does Mathcad help exactly? So it does a few things. It helps the enterprises in a whole and also helps the individual users or the engineers. So as an enterprise level, it prevents the loss of IP and improves knowledge capture. You have all your knowledge and calculations captured in a single spreadsheet that can be attached in your PLM system. It can be attached to your data in a very nice format and a very nice readable format. You can also optimize your critical designs and your engineering processes because all your data is stored in one single source of truth inside of a single spreadsheet. Or, in result of that, it will improve your product quality, speed up the time to market, and definitely improve compliance with regulations. We see this, being a big draw to Mathcad when you're really trying to make sure that traceability is there, and you know how an engineer got to the solutions that they did. So it's very important with compliance and regulations. Now, on the user standpoint, engineers, love this. I'm personally a mechanical engineer, so I see the value in Mathcad where I can, easily solve and document my vital calculations. I can see it in a professional format. I can combine text, math, graphics, and images all in a single worksheet, so we don't have to go, look at our reference manuals or textbooks to kind of figure out what the image that we use there or what our design looks like. I'm a visual learner and a visual solver, so I like to see exactly what's going on in terms of a graph or the actual image of our CAD data. So we can all store this in a single worksheet, keeping things nice and combined and all together, so it's more clear on what you're doing. And to kind of with all that together, it enables knowledge capture, which in these days is so important in the engineering field. Capturing the knowledge and discovering why you did something a certain way, and you can reuse that data and verify your designs through that method. So it's very, very important. That's kind of the end of our slides. We're going to kind of dive right into Mathcad here, and I'll kind of show you what I mean. So this is the Mathcad layout. This is Prime 3.1, so the latest release. Now it's a very easy to use user interface. It's a very recognizable standard, UI ribbon that we see in most common applications like Microsoft Office. You see this in Word. Just the basic tab, the different ribbon user interface. So the first thing we'll look at is the Document tab. This is where you can format actually how your sheet will look like, right? So there's a few things you can do here. You can turn it onto the draft mode, where this is basically a whiteboard where you can start typing in calculations. You don't really care about the format. This is maybe more for, I guess you would say, a napkin sketch. You just can type in long calculations, and we all know that those calculations can be quite lengthy sometimes. Or you have the very standard, you have the very standard page layout, where this is more of a report format, where there's no print preview in Mathcad. You get what you print out what you see here. It's just a standard page. You type in your calculations. It's very neat, well formatted, and this is definitely the way to do it these days. So a few more things you can add in terms of metadata to your actual documents, because that's very important. You can add information inside the header, the footer. You can put in the page number and the date, and we'll show you that in just a second, kind of what that looks like. But you can add some very critical stuff, and you can definitely make these pages formatted to how your company wants them and wants to see them. And that's where a company template will probably come in handy and have that tied to your PLM system or whatever you're using. So to jump right into an example of what Mathcad looks like and what it does and some of the functionalities, we're going to be discussing the deflection in a beam. We're going to do some calculations to figure out what kind of deflection we see when we apply a standard load to a beam. So some of the first things I'll show you is that it has very simple text formatting. We've seen all this in like Microsoft Word. We have a text formatting tab up top here. We can change the font. We can change the size of the font. We can center it. We can bold it. We can change the color. So very standard. It has all the functionality that you would want in a tool that houses your calculations and your text and your descriptions. So very great to see. We also have the standard metadata in the header and footer. We have the rev of this document, what page it's at, a quick description of the exact problem we're solving here. So we have a title page, very important to have in your calculations to describe what you're doing in the first place. And we'll start walking down here, and you can see that it's really important to keep things organized. Really important to see certain steps. What I like to do is first have a section 1 should be your assumptions, your initial variables, what your problem looks like, and then you have your calculations at section 2, and maybe your final section is analysis or a summary of your results. So what we'll kind of walk through this here. Go ahead and remove these X's. These are just placeholders to show me. Yeah, the header here. These are just placeholders to show me where I need to input some data. And what we can do is we can go to the Math tab, which is the pretty standard tab where you'll be inserting your math, your equations, your symbols, your operators, and we'll insert an image. We'll go ahead and find this image of the cross-section of our beam. And we have some variables that we need to input, so let's go ahead and input these variables. So it's also very simple to use. You don't need to go learn a new programming language to use this software. It's very standard notation. Nothing is complicated. Nothing takes a while to learn. It's a very short learning curve, so you can get up to speed. Your engineers can get up to speed as quickly as possible, which I think is very important. You don't want to have to waste a lot of time trying to learn the software. You want to kind of dive right into it and learn how you can start using it. So there are some very advanced functionalities of Mathcad which take some time to learn, and I mean they're pretty straightforward, but there's also very standard uses of it which doesn't require programming language. So we identified our two variables here. Now we'll go ahead and put in an equation to find the moment of inertia for this particular part. Now, as you can see, I made an error already. I put in h instead of d as that height there, which is pretty common. I mean, people make mistakes. H is a pretty common variable for height, but I put it in anyway. So let's see how that affects our end result here. So if I type in I equals, which evaluates our expression of I, we get some number with some units attached to it. Now, this is a little confusing because this number is A, extremely small, which doesn't make much sense, and the units are completely off. Now, H is green, which means it's an actual constant hidden inside Mathcad, which Mathcad has a bunch of different constants you can use, such as pi, and H happens to be one of those. So we know something's already wrong. So what do we do to resolve this? Well, we can go back to our expression and take a look at it and say, oh, okay, so it looks like I had a mistake here. It should be D instead of H. So if I delete that and add D and hit enter, it automatically will update the results below. Now, it's also very important is adding units as you go along. Units are very, very important to have in your calculations, and this is where I think Excel lacks. Excel doesn't really care if you're using meters or centimeters. It just sees the numbers, and that's where a lot of issues come up. And this is why I love Mathcad, is because Mathcad handles units very easily. So at the end of all these expressions, I'll just put the units of centimeters in this case. And as you see, it automatically updates that moment of inertia to have meters to the fourth as the units. Now, we can change this to whatever we want. If I want to make the centimeters, I can just by adding a C there. It goes to centimeters. Or if I want to make those inches, I can just type in IN and it will go to inches. So very easy to go change your units. There's no problem doing that. It does all the conversions internally, so you don't have to worry about figuring out what's the conversion between inches and centimeters or meters and inches. I mean, we might know some conversions, but some other conversions we might have to go to Google. And it's not just length units. It can be volume units, temperature units. So it handles those conversions very well. Now, to show you something that I think is fantastic is it also catches errors with units. And we always run into these with our calculations. Our units don't add up correctly, and we always forget about that. So for example, I'll show you what I mean. If we have B, which we know is the unit centimeters, and we add it to 2 seconds, we know we can't add centimeters to seconds. That just won't work. But in Excel, for example, it just sees 10 plus 2, and so you'll get 12 from that. Well, in this case, with Mathcad, it will give you an error. It'll say these units are not compatible, so you have to go back and figure out what you did wrong. And very important to catch these errors right off the bat instead of trying to find out why your answer is completely wrong and have to scroll through your entire document to figure out where's that issue. what did I do wrong? So it catches it already, and it gives you that nice red box. It shows you exactly where the error is too. Instead of just saying the units aren't compatible, it kind of shows you where that error is. And it's very good at checking your work as you go along, which we all know is very important. It reduces the time, you know, that it takes to design something and go through the solver. So very important. Now what we can also do, we all know that it's not as pretty to have a large Excel file or a large data set inside of Mathcad. I mean, we can put it in Mathcad, but sometimes we don't want to have 2 pages of material data inside of Mathcad. So what can we do here? We can actually import Excel data. So if I go to this read Excel function, I can browse for an Excel file and go to our elastic modulus of a bunch of different materials, and it'll pull up the Excel file inside of Mathcad. Let me just expand this so you can kind of see what I'm talking about. So we have a few things here. We have the material, the Young's modulus in gigapascals and PSI, and we can go find a certain area that we might want to have. For example, we can highlight this area right here, magnesium all the way down to brass and bronze, and we can insert that. And it creates this function for us. It finds the path of that actual Excel file, and then it adds that range at which we were working at for that data. So then what we would have to do is we go ahead and we can assign this to a variable. We'll call it data. Pretty straightforward. And we'll type in, and to evaluate to actually see that data, we type in data equals. And I'll just move this around so it's a bit more clean here. Very important to keep things clean and professional. So we can see that data come out in a very nice table format. We can obviously go ahead and change the actual range inside the expression itself, so it's very flexible in terms of that. We don't need the third column there, so we'll go ahead and change this to B17. And we can just click away or hit enter, and it gives an automatic update. Now the origin for these data sets are 0, 0. So the origin starts at 0, 0. So this would be column 1, this would be row 1. So that's kind of important to remember, and I'll show you what I mean, because we're going to go ahead and try to pull a value out of that. We're going to pull the elastic modulus of aluminum out of that by saying row 2, column 1, which is the aluminum alloy, and the value of 69 gigapascals. And then we'll go ahead and put those units on there. Make sure I get that right. We'll evaluate that. And you see it comes out as pascals. Now we can change that if we want. We can obviously put a G in front of that, and it'll just put it back at 69, or we can keep it as pascals. Really, whatever you want works. The next steps, we have to add the beam length, the required load, and the load position. Now you can see how well Mathcad keeps things organized. You can add these text boxes and you can move them around. You can adjust the font. You can do really whatever you want with it. But it keeps things organized for traceability purposes, right? You want to know exactly what you're doing and where you're inputting these variables and what they mean. Half the time we don't know what W means. We don't know that means load. I mean, that's a pretty standard thing to use, but when you get to some of these crazy variables and names, it's pretty good to have a description exactly of what you're doing. And we insert the length as 15, the load as 500 newtons, and that load position, which is, as you see from the diagram here, at about 11 meters, or at 11 meters. And we do some basic boundaries condition setup, calculations, and calculating the shear in a moment. Now, something I want to point out is some of these equations can get quite big, and sometimes it's difficult to understand exactly what you're doing. So, from some of these simple equations, we understand what we're doing and exactly what the equation is. But when you get to like an equation like deflection, it's very clear to see exactly what we're doing here. But in a program such as Excel, I don't know how you would read this kind of equation. I actually went into Excel and created the equation. Actually, I just did the first half of the equation. So just this first expression, I didn't even add this last expression. But I just add the first part of the expression here. And it looks like a bunch of letters and numbers with $sign B5, B2 squared. This is not readable. How do you know I didn't make a mistake in here? And if I did make a mistake, how do you find that mistake? So there's a big challenge here when you're working with engineering calculations and data, when you have equations that are pretty standard. I mean, deflection is nothing new. This is not an uncommon equation. However, how do you expect to read that in a program such as Excel? So for traceability purposes, it's extremely important to keep things organized when you can more clearly see what we're doing here, rather than look at B5 times B6, and I have no idea what those actually are. So it's very, very important to see. Now, Mathcad has two different function types. Obviously it has the built-in functions, such as the read Excel function that you saw before. It has other functions as well. There's over 700 built-in functions to Mathcad. But we can also define our own functions. As you kind of see above here, moment is defined as a function, deflection is defined as a function. And we can also evaluate those two. So if I put in y of L over 2 as half the length of that beam, and I evaluate it, it actually spits out the answer to what I'm looking for. Now, it's in meters, and I kind of want to get that a little bit more accurate of a number, so I'll type in millimeters instead, and see it's about -13.12, and that's the deflection at half that beam length. So about half the beam length with that load, we have about a -13 millimeter deflection at that point, which would make sense. Now, some other features you can do as well with Mathcad is it has two math engines inside of Mathcad. The first one is the standard math engine that does these calculations, arithmetic engine, I guess you would call it. The second one is a symbolic engine, and it allows you to solve for things and optimize your solution. So in this case, we're solving for the equation to calculate the maximum deflection. What do we need to find the maximum deflection? So as you can see, it does a derivative of the deflection equation, and then solves for x to find those two different values, and it spits out where it believes, given those values, where it believes the maximum deflection will be at. Now, we obviously can't have a negative value, so we can probably disregard that, but we know that about 8.3 meters, we should see our maximum deflection at that point. And I'm going to close this here, just minimize that, and keep it clean. And that equation is pretty standard. That simplified equation looks like this, and we calculated that point's about 8.385. And we can find that at that load point, y of a, there's a -11 millimeter deflection. We can also figure out where the maximum deflection is based on this equation we have above. And we can also figure out what the maximum deflection at that point would be. So before we had about -13.12 millimeter deflection at half that length. At the area where there's the maximum deflection, we'll have a -13.3. So just a little higher than that number before. And we can do a few more things. We can do some plots. We have our shear and moment diagrams, which are obviously pretty important to have. These are very easy to manipulate and use. We can go into our plots. We can change the color of our they call it the trace, which is the actual line. We can make a different thickness. We can adjust the range, the scale. We can do a different plot background, make it transparent or white. There's a lot we can do. Add a vertical marker, drag this along. We can add that. We can put this at. We can type in our own value. Type in my own value here. Let's just do 8.3, for example. And we'll go to that value. Let me move this down a little bit. And then so what you would have, so after we have our plots, then I think the best next course, the thing that makes the most sense is to have a summary of our calculations. So we have a table here that shows the difference in distances and then the deflection at those points. We have our end calculations, I guess you'd call it, to figure out where the maximum deflection would be, and some of the basic assumptions we had used beforehand. So we're just carrying all those basic assumptions down as a summary to kind of see what it looks like in the end. And then we have a nice plot of what that deflection looks like over x. And again, we can go through this, change that thickness, maybe make a different color, gray. That's not a good color. So we can really do a lot with these, right? And we can find out where that, at about 8.35, that's where our maximum deflection would be, right? Which would make sense. It's at this tip of this curve. So there's a few more things I want to show you guys before we kind of step into our Q&A section. There's a lot more with Mathcad. There's a lot of different advanced functionalities. We won't kind of go through the exact setup of these advanced functionalities. To give you an idea of what else you can do and how this can help improve your design and your engineering calculations, we can also do some programming as well. Now, in this case, we create a program where it finds that maximum deflection, how it changes as the load and the load position varies. So we were at about 500 newtons in the case that we were using, and which is around this area. We can see the contour plot here. But as you can see, if we get up to about 900 newtons, and that load is almost dead center of our beam, we're going to have a failure. So it's kind of interesting to see this as a contour plot. We can also create a 3D graph of this, as well. Just type in the same thing here and pop up a 3D graph. We can rotate this and do a bunch of fun stuff with 3D plots. And we can also create solve blocks as well. So this is kind of talking about optimizing our problems and our design. So we can minimize right here we're trying to minimize our moment of inertia, and then find out what dimensions we actually need to create the most optimum design that can handle the most load. So something definitely to dig into a little bit more and play with, but the functionality is there to optimize our designs and make them as robust as possible. And that's pretty much a good overview of what Mathcad looks like. And obviously there's a lot more that we can cover and talk about. And there's a lot more that it can do, but those are the main functionalities, and some of the main key things to see as kind of an overview is the unit intelligence. It really manages your units well, kind of taking out that need to manage them yourself in an Excel spreadsheet. It has complete interoperability with or integration with Excel. So it uses Excel quite fine. You can actually export data into an Excel file and also bring in data to an Excel file. And it keeps things organized, so the traceability is there, right? We keep things in sections, we keep things clean, we add descriptions, we add text to tell our end users or downstream users exactly what we're doing. So I think that wraps it up. Let's, if there's any questions, please feel free to ask them now, and we'll get to those. Otherwise, thank you so much for listening in.
So Dustin, I see a couple of questions over here. One of them that I was wondering if you could address first is, does Mathcad support integration with any of the CAD environments?
Yes, that's a great question. So Mathcad does have integration with other CAD environments. That's something that we can definitely show a little later, or in a future webinar, or maybe a one-on-one demo of it. But yes, so we see this with SOLIDWORKS, and we also have this with Creo, which is obviously a PTC product. But if you're using SOLIDWORKS, that's quite fine too. You would basically map the parameters that you set, or map the variables you have inside of Mathcad to the parameters or the tables inside SOLIDWORKS or Creo, and it handles it very well. And you will see your data and your CAD design update as you're putting in new calculations and new solutions inside of Mathcad. So it does a really good job at integrating with your different CAD systems. That's very fascinating to do when you start getting into that.
Well, awesome. So let us know if you wanted more details on that, and I'm sure Dustin will be able to help. And then the other question that I see over here is that can we make a template? Like, how can we edit Mathcad template for our company?
Oh, right. So yeah, this is something I meant to kind of bring up in the beginning. So with a blank sheet, it's pretty simple. It's very straightforward to make a template. All you do is you kind of create what you want to see, and then you can just output it as a template. But for example, as a header, we can go ahead and put in, our logo. Let's see, I think I put our logo in here. We have Tech 30, for example. Put our logo in there. We can put in, put in our name. Oops, let's see here. There we go. Name, title. We can add our metadata in here. So if we go back to our document sheet, we can add in the page number, right? This is probably want to put this on the footer. So let's go ahead and do that. Obviously, put a title for what you want here. Let's go to the footer and quickly do some adjustments here. Let's put the page number. And we just move these around kind of to where you would want it. I'm doing this pretty quickly, but you get the idea. And as you go through this, it'll update the save date when you save the actual Mathcad sheet. So you can see when that was last saved or last modified. You can add a few more things. I see a lot of people, they put in a kind of a description or what standard units they're using. So, standard, oops, let's see. Put in standard units, variables, right? So you would put in here, that you want to use meters, millimeters, what your constants will look like. If you have a specific, you have a specific constant relating to your actual design. I see a lot of that stuff going here, so this is a great area to make a good template for what works best for your company. And then you go to Mathcad and save as MCTX, which is save as a template. And you would just save this as a, I'm just going to put demo template. And then when you go to do a new file, you go new from templates, and then your demo template, and that'll open up. And it's pretty straightforward how you do it. Obviously, you could do a lot more to this and kind of make it a little bit more to what you guys want, what you think is best, but that's pretty much a really straightforward way to do it.
Thank you, Dustin. We have another question. We have a kind of an experienced Mathcad user over here. He's asking that will PTC try to improve the symbolic functionalities in the Prime version. The whole question is that he thinks that the symbolic functionalities through Mathcad 14 and 15 have been reduced, and is wondering if it will be a bit improved. So if you could address that, please.
That's a great question. Now, I don't know the exact changes between Mathcad 14 and 15 to Prime 3.1, so I can dig into that a little bit more and get back to you on that. I do know they did put a lot of work into building out the functionality for symbolics a little bit more. I don't know the exact specifications of what they did. All the functions in Mathcad Prime 3.1 are a lot more robust. They put, it's gone through a few iterations of Mathcad Prime, so there should be some more functionality built in. It really depends on the specific area you're running into, but Mathcad 15's a little old, quite older than this, and so I know that a lot of updates have been done since then. But please feel free to email us or email me directly, and with any specific questions you may have on that, and I'll definitely pull up some information from PTC about that.
And then we have another question also. Are there equation libraries written for Mathcad for various fields like structures, aerodynamics, all of those?
Yes. So there's a few things. Mathcad has a bunch of different pre-made templates for your specific field. Now, let's see. So these are housed in the PTC website. I can give you a direct link to that. There's a bunch of free ones that you can use. You can also purchase a library specific to your industry as well. But I've seen all of them from civil engineering to structural to all the different heat transfer, temperature, everything you might need. I've seen a bunch of different ones. I know they have several thousand pre-built worksheets that you can use. I think that's what I think it's fantastic. They're really nicely done, and they're very nicely organized as well. So I can give you a direct link to that, and where you can find those, and you can start playing with those and open them up and see what they look like. But I definitely recommend checking those out. I definitely do.
Okay, I don't see anything else. Let me just check one more time. I hope all of you have gotten your answers. Data will get back to you on the symbolic functionalities. You can email Dustin directly, so we'll have your contact information. Dustin, if you would please go to your contact information so everyone can have your information, that would be really nice.
Right.
And then please let us know if there was any other questions. Again, if you haven't seen by now, we will upload the webinar to our website. So if you wanted to access it at a later time, you can always access it through that. You can contact us through our website or Dustin directly. You can also call us. We will be always available to help. And really, thank you for joining us. And we really do hope that we can see you in the future in our web sessions.
Yeah, thanks, guys.
Dustin, do you have anything to add?
No, I left my contact information and Tech30's contact information up on the screen. Like I said, please feel free to contact me. I'll have Donia shoot out a message with the link to those free Mathcad sheets. And if you have any other questions, please feel free to contact us or contact me.
Actually, one more question came through, Dustin. So if you want to answer the last one, and the rest we can answer through email. Is there a way to send active worksheets to people who do not have Mathcad?
That's a good question. So you cannot send active worksheets to people that do not have Mathcad. What you can do is, and this is very common, is to export it, just save it as a PDF and send it off. But if they don't have Mathcad, there's no way for them to use that functionality that's inside Mathcad. But to share your data, just save it as a PDF, and it's very clean and it looks exactly like you would see on the screen, and they could see the calculations you've done and the solutions you've got. But there's no way for them to actually play with it and start inputting their own equations, unless they have the software themselves.
Okay, awesome. Thank you. So everyone, please feel free to email us again, call us. We will be always here to help you out with any questions that you might have. And again, thank you for joining us. Hopefully we will see you all again soon. Thank you.
Thank you so much.
And have a great day.